Okay, so because a couple people just popped into Zoom and a couple people just came into the room, I'm gonna give us like 1 more minute to try this warm-up problem. If we're looking for the equation of a line, I don't care which form it's in. But if you already found it in one form, you could try to find it in the others just for practice. Given that I have 0 responses in the chat and folks in the room seem to have more or less stopped writing, shall we do this together? So no matter which equation of a line we're going to use, we always need to start by finding a slope. And we can either get that from the picture because I've given us a picture, or by using the points. And I'm going to go ahead and use the points because we certainly will not always have a picture in terms of trying to find this. It doesn't matter which one I label sort of the first point and the second point, but I'm looking for the change in Y over the change in X. So I'm going to call this top one the first point and this lower one the second point. So I would be doing 0 minus 2 to get the change in the Y values over 3 minus 0 to get the change in the X values. So I'm going to end up with -2/3. Now we talked about this maybe the first day that we were talking about lines. And one of the things that we should be able to look at a graph and see is whether the slope is positive or negative, whether that slope should come out to be a negative value or a positive value. And because as we move left to right on the graph, we're going down, I know that the slope should come out to be a negative number. So far, so good. Now that we've got our negative slope of 2/3, we can choose either of the points to plug in to our point slope form, or we can use the slope intercept. Since we have a Y-intercept value right here, if my pen was working this morning, Y-intercept. Since we have a Y-intercept value, I'm going to go ahead and just use the slope-intercept form and say Y is equal to -2/3 X plus 2. Alternately, if you like the other form better, or if you just didn't notice that that was our Y-intercept, we can use either of the 2 points to plug into our point slope form. So I could have, okay, maybe nothing wants to write this morning. That's really fun. I could have Y minus 0 is equal to -2/3 of X minus 3. Or I could also have Y minus 2 is equal to -2/3 of X minus 0. And You do not need to write all three of those equations, but all three of those equations would be totally fine for a final answer. You could also put this into standard form, but honestly, we're just not going to use the standard form that much. Sometimes we're going to need to go from standard form into like a y equals mx plus b sort of situation, but very, very rarely would you be asked to actually write the equation in standard form. I'm never going to ask you to do it. Questions about this before we move on and practice some graphing of lines? Okay. Seeing no questions in the chat or in the room. If we're going to graph lines, really the only thing I need is 2 points. And if I graph 2 points and I draw the line that passes through them, I have graphed a line. Our textbook suggests having 3 points just so that you have an opportunity to kind of check your work. I don't need you to graph 3 points. So if you're graphing a line, 2 points will do. Personally, I think that finding the X and Y intercepts is always good practice because regardless of the function we're working with, the X and Y intercepts are often something that we want to put on the graph. So let's get some practice. So we're going to sketch a graph. And I'm like really, I'm gonna ditch this page because I actually think it's my fake plastic paper that's failing. So let's try this page. Much better. So if we're graphing lines, we should be able to graph a line from any of our 3 forms for the equation of a line. So if I had something like y equals 3x minus 7, I would definitely expect that looking at this, we should be able to read off that the slope is 3 and that the y-intercept is -7 or 0, -7 if we write it as an ordered pair. So we should be able to get a super quick sketch going just by noting that the intercept was a negative value down here at -7, and it has a positive slope. So I would expect you to be able to draw that much really without actually doing any calculations. Shifted down 7 for the y-intercept, and it's got some sort of positive slope. If I'm expecting you to label 2 points, that means labeling X and Y values. So -7 is not a point. It's only going to become a point if I write it as an ordered pair. That is my expectation when you're graphing, that those 2 points have to be labeled as an ordered pair. Now, the other point on here, we can label any other point, but I'm going to choose the practice of labeling my X-intercept as well. X-intercepts always happen when the Y value is 0. So this one in general is going to require a little bit of calculation, whether that's in your head or on the paper. But to find that X-intercept, I'm going to plug in 0 for Y, replace the Y with 0, and then rearrange to get the X by itself. So I can divide both sides by, or sorry, I can subtract. It's a Monday morning. Y'all know what I mean. I'm going to add 7 and divide by 3. So 7 is equal to 3x and x is equal to 7/3. Totally fine to just walk away and leave that as 7/3. In fact, that's my preference. is that you walk away and leave that as 7/3. Now, I happen to think that lines that are given to us in the y equals mx plus b form tend to be the easiest for us to graph. But let me give you one to quickly do on your papers. Let's go -1/2 x plus 5. So go ahead and get a quick sketch of that on your paper. Remember, you don't have to use graph paper. You don't have to have little tick marks. I do expect 2 points to be labeled. So you can plug in the 0 for x, get the y by itself, plug in the 0 for y, get the x by itself. I love graphing lines because even from across the room, I can usually see, does the slope look like it's going in the right direction? Is the intercept looking reasonable on your graph? And those are the only two things really that matter at this point in terms of these lines. So I'm looking at this thing and I know I've got a slope of -1/2 and a y-intercept of +5. So when I graph this, I need a positive y-intercept and a slope that's negative. Doesn't have to be perfect. I just need to draw something that looks like it's got a negative slope. I'm going to go in and label those points. So my y-intercept should always look like 0, something. My x-intercept should always look like a number, 0. Because at my x-intercept, my y value is always 0. If I plug in 0 for y, then I've got 1/2 x plus 5. We have choices for how to deal with this. Because there's a fraction and an equal sign, I'm going to choose to multiply everything by 2. Could I move stuff first? Absolutely. Am I going to? No, because I want to practice distributing things in. So 0 times 2 is 0. And over here, I'm distributing that 2 to the -1/2 x and also to the 5. 2 times -1/2 is going to leave me with a -1. So I've got -1x and then plus 10. Or if I add the x over x is equal to 10. Good times. I am not seeing questions in the chat. Trying to pause here just for a second. Actually, I'm pausing because it takes a second for my ink to dry on my plastic paper. I really do love these pens and my reusable paper, but it's kind of wearing out. So for me, the like harder lines to graph are always the ones that are not written in the form y equals mx plus b. So if I've got a line that's written as y minus 5 is equal to 2/3 of x plus 12. So this one looks a little bit worse, just visually. We can see, hopefully, that it is written in point slope form. So one option is to pull that slope and to pull the point off. However, if I'm going to end up graphing this and I want to label the X and Y intercepts, I'm not going to do any work to this directly. Instead, I'm going to start by plugging in numbers. You don't have to do it that way. You can rearrange this to make it look like y equals mx plus b. You can pull the point and the slope off and graph it from that. Personally, if I'm going to have to find the X and Y intercept anyway, I might as well just do that. So to find the X intercept, and no matter what the graph looks like, I'm always doing the same thing. To find the X intercept, we set y equal to 0. Well, if I do that, I've got 0 minus 5 is equal to 2/3 of x plus 12. We have choices. You can distribute that 2/3 in, move stuff around, or look at that and say, hey, I've got fractions and an equal sign. Why don't I get rid of them? That's going to be my choice. So I'm going to take both sides of this equation and multiply by 3. Times 3. And I didn't really need parentheses there. Stuff was already in parentheses, so times 3. In case it hasn't become obvious, all of the stuff that we did the first week and all that stuff in chapter 1, it's really just because it keeps showing up. So the time we spent talking about fractions, the fractions aren't going away. They're now just one step in the problem. And as you move on towards pre-calc and calculus, most of the stuff we're doing here, like for the entire quarter in this class, that's like one part of the calculus-y problem. So the goal is that we get faster, more efficient, and more accurate with this stuff so that you can concentrate on just learning the new stuff. Okay, so here I'm going to multiply both sides by 3. On the left-hand side, 0 minus 5 is -5, and 3 times -5 is going to give me -15. On the right-hand side, I have 3 things that are multiplied together. So I can multiply those in any order I want. I'm going to multiply the 3 by the 2/3 to get 2. And then distribute that out. That's 24. So if I subtract 24 from both sides, I'm going to get -39 is equal to 2x, or x is equal to -39 over 2. It's gross, but that's okay. I'm pausing there just in case there are questions or if I've made mistakes.
So you're multiplying, right? You're distributing for all of them.
Yeah, so let's take like a little side note here, because if I were multiplying 3 numbers together, like if I had 2 times 6 times 1/3, I don't multiply the 1/3 times the 2 and get 2/3, and then multiply the 1/3 times the 6 and get 2, right? Like I have 3 things multiplied together. You can multiply them in any order you want, but I'm not gonna like take the 2 times the 6 and the 2 times the 1/3. So if I look here, I don't know what the value of X is, right? But once I've chosen a value for X, it would be a number. And that number plus 12 means that that stuff in parentheses is a number. So 2/3 is a number, the stuff in parentheses is a number, and the 3 is a number. And I can choose what order to multiply them in. So I chose the order of 2/3 times 3 and then times this other thing. It is confusing and a stumbling point for lots of people. And I think, your brain wants to distribute stuff. Now, as an alternative, you absolutely could distribute the 3 and not multiply it by the 2/3 yet. So you could do 2/3 and then distribute the 3 into the parentheses instead. And get 3x plus 36 and then distribute the 2/3 back in. But that would be gross. So that is not the choice I made. Also, it's possible I can't do math. So I wrote -32. That was the problem. I wrote the wrong thing. Cool. There we go. Oh, by the way, if you were to multiply the 3 by the X and the 12 and also times the 2/3, you would have actually multiplied by 9 because you multiplied by 3 twice. Okay, all of that. We still don't have Y-intercepts, so we got to find Y-intercepts. Y-intercept happens when we set X equal to 0. I guess I should leave the equation on there. So if I set X equal to 0, I'm looking at Y minus 5 is equal to 2/3 of 0 plus 12. Well, this one isn't quite as messy. We could definitely multiply both sides by 3 right now, but I'm looking one step ahead and seeing that 2/3 times 12 is already going to get rid of my fraction. So I'm not going to make numbers bigger if I don't need to. So I'm going to have Y minus 5, 2/3 times 12. But I'm going to write that 12 as 4 times 3. So that I end up with 8. And then it looks like my Y-intercept would be 13. And I got all I need to be able to sketch a graph. It doesn't matter how gross they are, but this is definitely a place where I strongly advocate not trying to make little tick marks on your axes because the numbers are gross and then you have to figure out where -39/2 is. But if I just label it as -39/2, 0, and then I just label this as 0, 13, I'm good. There's my line. Shall we do another slightly gross one? I didn't make it that gross. There are no fractions. I could give us fractions. Should I give us fractions? Now we'll leave it without fractions for the moment. So find the X and Y intercepts. I will let you all do that on your paper. Anyone want to be brave and tell me what they got for X or Y intercepts? By the way, I don't do this a lot, but the book often draws like tables of numbers to track X and Y values. Okay, we got someone brave. We got a 24 and sorry, a 21 and a 4. Anyone got either of those numbers anywhere? Oh, sorry, 21/4. I lied. I thought it was two separate answers. 21/4. Cool. So let's see if we can get that 21/4 together. So if I'm trying to find the X intercept, I'd plug in 0 for Y. I have 0 plus 1. No fractions here, so I'm going to go ahead and just distribute. Get 4x and then minus 20. So when I add that 20 over, we'll have 21. And it looks like that 21/4 is, we got 2. In terms of the Y-intercept, if we plug in 0 for X, then I've got Y plus 1 is equal to 4 times 0 minus 5, or Y plus 1 is equal to 0 minus 5 is -5. 4 times -5 is -20. And Y would be equal to -21. Oh, did I put those in the wrong spot? Looks like I put that in the wrong spot on my table. So if we are reading the table the way that they're written in the book with those X values in the first column and Y values in the second column, then that first point we got by plugging in Y equals 0. So that would have actually come down here as our 21/4. And here, when we plugged in 0 for X, we got -21. That looks better. And now if I put those onto a graph, Y value, -21. And again, I'm just going to label it as 0, -21 and not worry about exactly where it ended up. And then I need an X value of 21/4. Fine, we're just going to call that 21/4, 0, and draw our line in. Comments, questions, more fun with things? Okay. Well, we've done some of these with point slope and we've done some with slope intercept. We might as well do some where our equation is written in standard form. So let's say I'm looking at 2x plus 3y is equal to 24. So it is important that we're able to recognize that this is the equation of a line. My X and Y values both have exponents, invisible exponents of 1. So I know, and we're adding them together. So I know that that's the equation of a line. And if it's the equation of a line, I ought to be able to find the X and Y intercepts. And also it might be important for some context to find the slope. But for now, let's just find the X and Y intercepts so that we can sketch the line. Same process I'm going to do as the other problems. To find that X intercept, I'm setting Y equal to 0. And to find the Y intercept, I'm setting X equal to 0. Well, if I set Y equal to 0, I'll have 2x plus 0 is equal to 24, which must mean X is equal to 12. I made the numbers nice this time. And if I set X equal to 0, I'll have 0 plus 3y is equal to 24, which means Y is equal to 8. When I put that on my graph, I do want to make sure that I'm labeling both of those as points, as a coordinate pair. So X was equal to 12. So that's 12, 0. And my Y was equal to 8. So that's 0, 8 as an ordered pair. Now, from looking at the slope on the graph, I know whatever else is going on with the slope, it's got to be negative or less than 0. So there's a question in the chat about, there's a question in the chat about my zeros, and for completeness, I could have written this 0, for example, as 2 times 0. And I could have written this 0 as 3 times 0. I honestly was being lazy. So my apologies for that. It's a Monday morning. So 2 times 0 is 0. So I was kind of skipping that step. But for sure, when we're plugging in the 0, it would be more accurate to have written it like this. Or at least it would have been a nice intermediate step to have written it like that. For sure. Okay. Would anyone like one more example of these before I move? Okay, I saw some head nods. Let's do another one, and I'm going to make the next one. Oh, question. Oh yeah, that's a great question. So how would we find the slope, right? I just said that it was less than 0, but we didn't actually find it. Well, now that we have the X and Y intercepts, I would find the slope using those. So I would be looking at my change in Y over the change in X. Again, it doesn't matter which we call like the first point and the second point. By convention, we usually go first point is on the left, second point is on the right. So I would say that my Y values, my change in Y would be 0 minus 8, and my change in X would be 12 minus 0. So I would get -8 over 2, 12. Or if we put that into lowest terms, I can think about the top as saying 4 times 2 and the bottom as being 4 times 3. So my slope would be -2/3. Now, if you really, really, really like memorizing stuff, you can certainly memorize that when our equation is in standard form of ax plus by equals c, that our slope is -a/b. But honestly, I do not recommend trying to memorize this. Anytime you're being asked to deal with an equation in standard form, you're probably going to have to find the X and Y intercepts anyway. And if you just remember how to find X and Y intercepts and how to do the slope as change in Y over change in X, it's less to try to keep in your head and more versatile for other problems. So that would be my recommendation. But if you like love memorizing formulas, that's an option. Okay. Let's do one more of these before we move on to graphing inequalities. Um, 2x minus 5y is equal to 7. I'm going to start in the same place by finding the X and Y intercepts. So X intercepts, we always get the same way. We plug in 0 for Y. Y intercepts, we always get the same way. We plug in 0 for X. Well, if I plug in 0 for Y, then my equation is going to become 2x minus 5 times 0 is equal to 7. 5 times 0 is 0. So that's like 2x minus 0. Or 2x is equal to 7, which means x is 7 halves. If I then find my y-intercept by plugging in 0 for x, I'd have 2 times 0 minus 5y is equal to 7. Or 0 minus 5y is equal to 7, which means y is equal to 7 over -5. And I know I brought this up a couple times. I can also write that as -7 over 5, and I can also put the negative sign out in front. Any of those would be fine. Whatever sort of makes more sense in your head. So if I go to find our graph, my x value is something positive, my y value is something negative. I'll just come back in here and label this. So this was 0, -7/5. And then this one was 7 halves, 0. And just for fun, if we wanted to find the slope, we do not need to in order to graph it. But if I wanted to find the slope just for practice, and I'm thinking about a change in y over a change in x, again, I'm going to choose that the point on the left is my first point and the point on the right is my second point. So for that change in y, I would have 0 minus -7/5. And then I would have 7 halves minus 0. Minus a negative, I'm going to choose to rewrite that as a positive 7/5. And then we are dividing by 7 halves. But this is the place where dividing by a fraction, I can rewrite as multiplying by the reciprocal. I think I can squeeze it in over here. So if I rewrite that to say 7/5 times 2/7, then my 7/7 becomes a 1. And I am left with 2/5 as my slope. Which if we go back to the formula that I don't like, because it's just extra stuff to memorize, that matches up. So if I took the negative of the coefficient in front of X and I divided by the coefficient on Y, we would have -2 over -5, and we'd have +2/5, which is the same thing we got by doing it this way. So either one works. Sorry. Okay. We got 8 minutes left, which honestly is plenty of time for our next thing. So far, all of the things we've been graphing have been linear equations, meaning there was an equal sign, but we also need to be able to deal with linear inequalities, meaning we'll have a less than or a greater than, or a less than or equal to, greater than or equal to. So if I'm graphing a linear inequality, that might look like something, let's say I've got y is greater than 2x plus 1. So this is just telling me that I want to include every possible solution to this equation. Meaning for a given x point, like for a given number in x, what are all of the possible y values that would be a solution to this? The easiest way to do this graphically is first to think about what the y equals 2x plus 1 graph would look like. And we have the slope is 2 and the y-intercept is 1. So if I were graphing this, I know that I'd have a y-intercept at 1 and I could sketch in a positive slope. Because this is a greater than, but not or equal to, when we sketch the line, we're actually going to sketch it as like a dashed line, not a solid line. Because we don't want to include the specific combinations of x and y that would make this equal, because it's not true over here. The next step in graphing the inequality is to choose a test point. Because what this has done is it's divided the plane into 2 pieces. And in one of these 2 regions, all of the x and y pairs will make this true. And in the other region, all of the x and y pairs will make it false. So we're going to pick a test point that you are for sure know which side of that line you're on. So for me, 0, 0 is currently an easy test point to pick because I for sure know which side of the line I'm on. Another easy test point to pick would be anything on the y-axis, because I know that this y-intercept is 1. If I pick the point 0, 2, I know it's up here. If I pick the point 0, -1, I know it's down here. So I would say anything on the y-axis is a good choice. I'm going to choose a test point of 0, 0. So if I test 0, 0, I want to know, does it make the inequality true? So if I plug in 0 for y, and I'm going to give myself a little question mark about the inequality because I'm testing it. 2 times 0 plus 1. So is 0 greater than 2 times 0 plus 1? Well, 2 times 0 is 0. When I add 1, I get 1. So this is not true. And if it's not true, it was not true here, which means the other side of the line is the side that I want. And we can shade it in. Let's do another one. So y is less than or equal to negative 3x minus 4. This one does have, that was a dashed line because it did not have the or equal to. This one is the less than, than or equal to. And because of the or equal to, this is going to be a solid line. So if I think about graphing this thing, I can see that we have a negative slope and also a negative y-intercept. So I've got this y-intercept down here at -4, and a negative slope means it's going to look something like this. I made it a solid line this time because of the or equal to, but I still have to find a test point. Again, I'm going to pick 0, 0 as a test point. So I'm going to say, is 0 less than or equal to -3 times 0 minus 4? So is 0 less than or equal to 0 minus 4? And that's not true. Which would mean that I would shade the other side of the graph. By the way, just for fun, and just to show what happens if we had picked a point that did make it true. So let's say that I picked a different test point and I actually said, okay, well, I'm going to test 0, -5. Well, if I test 0, -5, then that would say, is -5 less than or equal to -3 times 0 minus 4? So is -5 less than or equal to 0 minus 4? And that is true. So if that had been my test point, I would say, oh, okay, so shade the side of the line that includes that test point. Looks like I am out of time for today. I am going to stop our recording.